Alright, on page 468, let's look at the quick review first. We'll do it a little different this time. Let me just remind you that when you're simplifying fractions, and that's what we'll be doing here, we're putting them in their lowest terms. Remember, terms means numerator and denominator. Putting these in their lowest terms, these all need to be simplified, so we need to divide each one by the same number. And remember, the trick is to find a use your skip counting songs. Go through your skip counting songs, and if you find both of those terms in that song, you can divide them both by that same number. So let's think through our fours. Go ahead and not fours. So look at number one. Look at number one on page 468 in the quick review. Quick review. Page 468, number one in the quick review. Let's try our threes. Okay, let's sing our threes.
3, 6, 9, 12, 15.
Okay, hold on. Were both of those terms in that song?
Yes. Yep.
So that means you can divide them both by 3. Okay? So now, in your mind, divide them both by 3, not on your whiteboard. In your mind, divide them both by 3, and tell me the equivalent fraction. Go. Just say 4/5. Thank you, Joseph. Okay? Joseph gets to sit that one up. Sit these out now. Okay? So, try number 2. 1/2. 1/2. Karis can sit up. Okay? Alright. Try number 3. 4/6.
2/3.
2/3. Stephanie can sit up. Okay? Try number 4. 6/24.
1/4.
1/4. Okay, I'm gonna let both Lucy and Alyssa sit up. Okay? And then the last one, 7/28.
1/4.
1/4.
Yeah,
1/4. Kate can sit up. Okay. Right. Now, if you can just, if you can, am I videoing? Yes, I'm videoing. Good. Okay. If you can do it without the skip counting song too, that's fine. But that's a nice little trick to help you with that. All right. Now we're going to be adding fractions together. Okay. Now we're going to be adding fractions. All right. But we're mainly going to look at 469 today. But first, I kind of want to show you how this works. All right. Let's say I've made some pizza, all right? And you say, oh, that's some pretty good looking pizza, all right? I've cut my pizza into 4 equal slices, okay? There are 4 equal slices to my pizza. And you say, Mr. I'd like some of that pizza, okay? I say, sure, you can have a slice, all right? So, I give you a slice here, and let's make this look like a 4th here. And remember, I cut it into 4 equal pieces, so as a fraction, you could say you got how much of the pizza?
1/4.
1/4. All right, 1/4. Okay. And you say, hold on, Mr. I'm really hungry. I need more than just 1 slice. I need 2 more slices. So I give you 2 more slices. Okay, let's try to make this look nice. Okay. Alright. So how many more pieces have I given you? I've given you 2 more pieces. But as a fraction, I could say that's what? Anyone have one?
3/4.
No,
2/4.
just these 2. Just these 2. I've got 2/4. Okay. So when I'm adding the fractions, I've got 1/4, I gave you 1/4, and you wanted more, so I gave you 2 more, so I gave you another 2/4. And how many do I have total, everyone?
3/4.
Okay, I've got 3/4, alright? I'm going to put my answer down here. Okay, 3/4. Now, what do you notice about my terms? What do you notice about my terms when I added those fractions, Stephanie?
You didn't add the bottom ones, but you added the top ones.
I didn't add I did add my numerators.
But you didn't add
I did not add my denominators. But it makes sense when you see it in the picture, right?
Yeah.
Because here's a 4th, here's 2 more 4ths, and you can just count them up and say that's 3/4, right? Okay? That's how it works with fractions. It's just like if we did cookies instead, and it wasn't a fraction, if I gave you 1 cookie and I gave you 2 more cookies, you'd have 3 cookies.
Yeah.
Same thing with fractions. I give you 1/4, I give you 2 more fourths, and you have 3/4. Okay, think of a fourth as kind of a thing that I'm giving you. Alright. So when I add my fractions, I do not add my denominators, I only add my numerators. Okay? So I could write it sideways like that. I could have 1/4 plus 2/4, or I could write it, as I would normally add something up, have them on top of each other, and do my addition sign and do like that. I could do it that way. But I always want to only add my numerators. End up with 3/4. Okay? See how that works?
Yes.
Let's look at another one. Let's look at one in our book. Okay? Look at page 469 at the very top. Very top. A little story about Pam there. So Pam, what if Pam walked 3/10 mile from her class to the library, and then 7/10 of a mile to get home? We want to know how far she walked. Okay, so look up here. She walked 3/10 of a mile from her classroom to the library, and after that she walked 7 more tenths of a mile to get home. Okay, not on a whiteboard channel, just look up here. Just look up here. Okay. Remember, I only add my what, everyone?
Numerators.
I add my numerators. 3 and 7, I get what?
10.
10. You gotta write it as 10 tenths. Now, remember, this is what we call an improper fraction. Improper fraction. We could convert it to a whole or mixed number by dividing, right? We could say 10 divided by 10 and we get what?
1.
1. 10 divided by 10 would be 1. But when you got the numerator and denominator of the same number, you should know right off that that's the same as 1. Okay? So in its simplest form, you should just write 1 mile. 1 mile. Instead of 10 tenths of a mile, you should just write 1 mile. Because that's what that is. Okay? Question, please. Okay, then hold off till later. Okay. That you made it. Alright. So we see what we're doing here. If I add them together and I end up with the numerator same as my denominator, well, that's just 1 whole. Okay? Now, if my numerator was bigger than my denominator, then I need to divide in order to make a mixed number, right?
Yeah.
Okay? Question, Karis?
Yes. So if you have like 5 and 5, would that just be 1 mile?
If I had 5 tenths plus 5 tenths?
No,
Yes.
it's like 5 fifths.
5 fifths?
Wouldn't that just be the whole thing? That's what you basically.
If we were dealing with fifths, yeah. If we had 5 fifths, it would be 1.
Looks like that.
Yeah, if 5 fifths is equal to 1, 6 sixths is equal to 1, 7 sevenths is equal to 1, any of those are equal to 1. Okay?
It's like that.
Alright. It would be just like that, yeah. Alright, so let's look at the examples. You can do these with me on your whiteboard.
Okay.
Now we have 2 tenths. And your book is written sideways, but I'm going to write it like this. 2 tenths plus 6 tenths. Okay? And we'll your whiteboard, your marker. Write this on your whiteboard. Don't do any more than that. Just write what I wrote on the whiteboard. Do not work ahead. When we work ahead, we end up missing some things. Okay? I want you to know the steps. So just write 2 tenths plus 6 tenths. Make sure you put the line there at the bottom. Here, put the line. Karis, question?
Is it okay if I do both ways?
I want you to write it the way I wrote it on the board. Here. Alright. Now, what do? We only add our numerators. So I have 8 tenths. Okay? Now, we're at 8/10. Now, I want my fraction to be in its simplest terms. Is this fraction in its simplest terms?
Nope.
No. No. Because I could divide 8 and 10 by the same number, couldn't I?
Yes.
What number is that? Just say it.
2.
2. Okay? Divide 8 by 2. Divide 10 by 2. I'm going to have 4/5. So that's really the answer I want you to have when we do these things. I want you to have it in its simplest terms. In its simplest terms. Okay? Have the number in its simplest terms. So this would be the answer you need to put down. Okay? Make sense?
Yes.
Any questions? Does not make sense? Okay, what does not make sense?
I can't.
You can't see? Well, that would make it not make sense. Now that you see it, does it make sense now?
Oh, yeah, no.
Okay, good, good. But sometimes that helps. Sometimes that helps. Just if you see it, then yeah, sure, it makes sense. Yes?
If you did it how the book would do it, how would you get...
You didn't have a what?
If you did it how the book was doing it, how would you get it like this? Would you just do...
I want you to do how the book is doing it there. Okay. Is that what you're saying? You didn't have to do it how the book was doing it?
If you did, this wasn't allowed.
Oh, it's allowed.
And
It's allowed.
If it wasn't...
No. It's allowed. Let's not worry about if it wasn't. It is allowed. So that's what you do. Okay?
If you did this, how would you get this?
This is how we do it. This is how we're not going to worry about other ways of doing it right now. We're going to do it this way because that's the best way. Okay? Alright, so let's not worry about other ways. Let's just worry about doing it that way.
This way or that way?
We did it that way. Are you talking about how it's written out this way instead of that? It just set it up like you're doing an addition problem. Okay?
Oh,
That's what you want to do.
They would do like, 10.
I mean, it both comes to the same answer. Whoa. Where are you coming to 10/11ths?
Because...
Where do you see 10/11ths? Okay. It's best that you just think about what we are doing and not think about any what ifs. Okay? Let's not think about any what ifs. Let's just focus on what we're doing. Okay? Okay. Yes?
Can we erase our board?
Yes, you may. Alright? Let's do the example B. Alright? 3/8 plus 5/8. Okay, 3/8 plus 5/8. Write that down on your whiteboard. Yes.
Are we allowed to do it?
No. Just write what I wrote on the board. Listen, the reason I make y'all slow down is it seems simple now, and it is simple now. But you gotta know the steps. You gotta make sure that you slowly go through the steps, because later on when you're in junior high and high school, it's gonna be a lot more complicated, and you have to make sure you do it step by step. You really, because you're not gonna be able to do these things in your head. When you get to junior high and high school, you will not. I guarantee you will not be able to do these things in your head. Is there a question about adding fractions? Question about adding fractions? Yes?
So when you get there, and you like add both of these up, I don't understand. After you do that, don't you like do 3 divided by 3?
Hold on. First let's do it. Go ahead, 3 plus 5, everyone?
8.
8. So you only add your numerators, denominator stays the same. Now you've got 8/8. Okay? And remember, if the numerator is the same as the denominator, what do you have?
100.
1. Okay? So you need to write for your answer 1. 1. Yes.
Is it allowed to be called 1 whole?
You could say 1 whole. You could. Joseph.
Wait, so you're saying if you do any number and they're the same as the number below, it's a 1?
Anytime the numerator and denominator are the same, it's 1. Yes. Alright, now let's do one more of these together, and then I'll have you do some practice problems.